Let's say this image is our original footage. We create a look and adjust the shadows to make them brighter. However, early in the process we crush the shadows, pushing them below zero. Then we decide to adjust saturation using a subtractive method, like HSV. Here's what happens. The crushed shadows instantly turn into a large artifact. And notice, I haven't even touched the saturation yet. All I did was change the node's color space. HSL does the same thing. So does ColorSlice. Inside ColorSlice, as soon as we adjust any parameter, saturation, density or vectors, we start damaging the image. That's because ColorSlice is essentially an HSV or HSL method combined with a qualifier. So why does this happen? HSV and HSL color models are designed to work with values in a range from 0 to 1. When converting from RGB, any value outside this range, like our crushed negative shadows, gets clipped or reinterpreted. This effectively destroys the shadow information. While these models also handle values above 1 by clipping them to white, in DaVinci the conversion affects the shadows only. Now let's compare this with traditional saturation tools based on the RGB color space. HDR saturation, when maxed out, looks destructive, but in a different way. If you watch the scopes, they look distorted. On the other hand, saturation from the primaries behaves smoothly. It gives us exactly what we expect from a clean saturation tool. So how do we get that nice subtractive saturation without the artifacts? I came up with a simple solution. Instead of converting RGB to another color space, which forces us to clip those problematic negative values, we stay in RGB. This way, we preserve all the information, including the shadow detail. The trick is this. Rather than pushing color channels toward or away from the luminance level, like primary saturation does, we find the channel with the highest value and push the others toward or away from it. I have implemented this logic in an open source DCTL, which you can find on my GitHub. It gives you the same visual result as HSV saturation, but without any artifacts. Let me know what you think in the comments and hit the like button. Once I had this working, I started thinking, why stop at subtractive? So I expanded the idea and added 6 more types of saturation to the DCTL. Let me walk you through them. First, standard primary saturation. This is just the regular saturation from the primary stub. I included it for convenience and comparison. Then we have middle-based saturation. Instead of using the highest channel as our target, we find the middle channel and use that as the base. Next is additive saturation. Here we use the lowest channel as the base. As you increase saturation, colors actually get brighter. This is the opposite of subtractive saturation, where colors get darker as you add more saturation. And finally, 3 channel-specific modes: red base, green base and blue base saturation. In these modes, we use a specific channel as the base, regardless of whether it's the highest, lowest or in between. Here's what's interesting. The behavior changes depending on the color. Take red base saturation. For example, if you are working with reddish colors, where red is already the dominant channel, you'll get a subtractive feel. Colors deepen and darken. But with bluish colors, where red is the lowest channel, it behaves additively. Colors become brighter. And for colors where red falls somewhere in the middle, you get a middle base behavior. So with this single tool, you are not just getting one type of saturation, you are getting 7 different approaches, all working cleanly in RGB without damaging your image with conversions. So what's the takeaway? Avoid crushing your shadows in the first place. Disable any unused nodes, especially those with internal color space conversions. And remember, sometimes the older, simpler tools are still better. Old but gold.